Okay, so greetings to my respected COA lecturer, Dr. Aida. So my name is Wei Zhong, and I would like to start the presentation on Lab 4, Program 1. So we will have first to include the Irving32.inc. Next, in this data type, we have to assign all the data type and also its respective values in these variables. Like for example, we have to assign an initialized to the D-word type of site x1 and site x2. Next, for parameter hexagon 1, parameter hexagon 2, and total parameter, the data type for 3 of these variables will be D-word and the value are 0. Next, there will be 6 strings in this data by using the byte data type. Like for example, enter a site value for hexagon 1, enter a site value for hexagon 2, parameter for hexagon 1 with site, parameter for hexagon 2 with site, the total parameter, and is. All of these strings are 0. Moving on, we're moving to the .code segment. We'll first start the .code segment with main PROC. We have to move the offset string 1 into EDX, and we have to call write string and call read integer. We also have to move EAX into site x1. After doing all of this, we will move offset string 2 to the EDX, and we will have to call the write string and call read integer again to present the string and also the integer that has been typed in the keyboard. Next, we'll move the EAX into site x2, and this move 6 is into ECX register is very important as we have to create the looping process for about 6 times, about adding the site x1 for 6 times and to obtain the parameter for hexagon 1. We will move the parameter hexagon 1 to the EAX register, and we have to move the EAX register to the total parameter. We will move the offset string 3 to the EDX register, and we have to call write string again to present the string, and we have to move the site x1 into the EAX register, and we have to call write integer again. We will move the offset string 6 into the EDX register, and we have to call write string again. We'll next move the parameter hexagon 1 to the EAX register and call write integer and call CRLF. Next, we will do the same thing again, which is move 6 into ECX to create the looping in adding the site x2 for 6 times to obtain the parameter hexagon 2. Next, we'll move the parameter hexagon 2 into the EAX register and add the EAX into the total parameter. We'll move the offset string 4 into the EAX register, call write string again, move the site x2 into the EAX register, calling the write integer again, move the offset string 6 into the EDX register, call the write string again, move the parameter hexagon 2 into EAX register, call write integer and call CRLF. At the last segment of this .code part, we will move the offset string 5 into the EDX register, and we will have to call the write string again to present the string. And we will have to move the total parameter into the EAX register, calling the write integer, and last but not least, call CRLF to clear whenever strings that is not required after this. Last but not least, we will exit the .code, exit the main in ENDP, and last but not least, we will end the main ASM for this program 1. Now I will show you the output for this program. Enter the site value for hexagon 1. I will put 35. And the site value for hexagon 2, I will put 7. Okay. And yeah, so the parameter for hexagon 1 and parameter for hexagon 2, they will add the site for 6 times, and the output is 210 and 42. And the total parameter for both of these hexagon is 252. Okay, so now I would like to share my reflection after doing this lab. In this lab, I'm able to learn more knowledges in computer organization and architectures, such as calling the library functions such as the write string, read integer, and call CLRF. All of these library functions are very important, as when we are required to use those functions, we will have the ability to call that out so that our program can be a success. Last but not least, I have also learned how to become more technologically in using the Visual Code by coding all of this in this main ASF project to make this project a success. Next, I will pass to King Kiat to present his question 2, and thank you for watching my presentation on Program 1.
Salam and good day, Dr. Aida. I am King Kiat and metric number A21EC0211. In this video, I will explain Program 2, which is about to multiple to unassigned number using multiple addition. First of all, we need to include a y32.inc library, and let's move to the data section. In this section, we have a few variables to declare. The first variable is multi-picken. We declare it in double word data type, and it doesn't have any initialization value. The second variable is multiple, and the third variable is product, and both of them are also has a double word data type and doesn't have any initialization value. The next variable is input 1, and its data type is in byte, and the content of the input 1 is please enter a multiplication 1 to 9. And the input 2 also similar to input 1, but the content is please enter a multiple 1 to 9. And then we move to the output 1. It has also declared in byte data type, and the content is multiplication of. And then output 2 is similar, but the content is x. Output 3 is also similar from both, and the content is the product is. So now let's move to the coding part. First of all, we need to move the offset input 1 into the register EDX. We call the write string library procedure, which writes a now terminated string to standard input. Then we also call the read int library procedure, which reads a 32-bit signed decimal integer from standard input, and it will be terminated by the enter key. Next, we move the register EAX into the multiplication, and then we move the offset input 2 into the register EDX. Then we call the write string and read int library procedure. Next, we move the register EAX into the multiplier, and we multiply the multiplication. Then we move the content of the register EAX into the product. Then we move the offset output 1 into the register EDX. Then we call again the write string library procedure. Next, we move the multiplication into the register EAX. Then we call write DEC library procedure, which writes an unassigned 32-bit integer to standard output in decimal format. Then we move the offset output 2 into register EDX, and we call write string library procedure 2. Next, we move the multiplier into register EAX, and we call the write DEC library procedure, and then we call CRLF library procedure, which writes an end of line sequence to standard output. Next, we move the offset output 3 into register EDX, and then we call again the write string library procedure. Next, we move the product into the register EAX, and then lastly we call the write DEC library procedure. And that's all of the coding part. And then Now we will try to debug the program. Start without debugging the program. And then here is the output. The program will ask us to enter a multiplication 1 to 9. So we input 7, and then it will ask us to enter a multiple. We also input 7. And then here is the output of the program. It will show multiplication of 7 by 7, and the product is 49. So that's all of the program. And now I will share some of my reflection through this lab. After doing this lab, I have learned about something new, which is called library procedure. With the presence of the link library, we can simplify our code. For example, we can call write hex to show output in hexadecimal number. We don't have to do a lot of steps to show hexadecimal, and it can also save our time. So the link library is one of the most important aspects in programming, as they are useful for us. So that's all for me. Thank you for listening.
Hi, my name is Tan Jiao Ting, A21EC0135. Now I want to explain about the question 3 in the lab 4. First, in the dot data, we need to have the hello double work, total or double work, total even double work, and string 1 by integer, enter integer, string 2 is to total even is, and the string 3 is total or is. And next to the main code. And the first, we need to set the number of loops for the input due to, because for the question, we need to ask the user to input the value of sex of integer. So we need to set the number of sex move into the register ECX, and 0 move into the EBX, and offset the string 1 move into the EDX, used to point to the string 1. So in the L1, we need to call the write string and read integer to read the input, and move the register EAX into the hello EBX, and add the number 4 into the register EBX due to update the value of EBX for the address. And we call the CRLF and loop the L1. Next, we also need to set the number of loops for the addition. Is the first, we need to set the number of 3 move into the register ECX, 0 into the EAX, and the 0 into the EBX. And in the L2, we need to add the hello EBX with the register EAX, and add the number of X with the EBX, and loop the L2. And then we need to move the register EAX into the variable total even, and offset the string 2 move into the register EDX due to point to the string 2. So then we need to call the write string and write EDC to display the total even number, and call the CRLF. And then next, we need to set the number of loop for addition. And so we need to set the 3 move into the ECX, 0 move into the EX, and the 4 move into the EBX. In the L3, we need to add the hello EBX into the register EAX, and add the number of X with the EBX, and loop the L3. And we need to move the EAX into the variable total odd, and move the offset string 3 into the register EDX due to point to the string 3. And we need to call the write string and the write EDC to display the total odd number, and we call the CRLF 2 times and exit the program. And this is all for the code for the program. Question 3 in the left form. Now we need all the output. Okay, in the debug console screen, we can see that total even is the 1, 2, 3, and the total odds is 20x. So that's all for the question 3 in the lab 4. Okay. Now I want to give the one reflection about for the lab 4. In this lab 4, I have learned about the right string, how to use the right string and the right DC and read integer, because we need to ask the user to input the value, and the last I learned about the how to improve the program code. That's because the program have many logic, and we need to find the best way to show the correct output. And that's all for my reflection, and thank you.